How's it going, AS Math? It is Mr. Knight, back at it again, fresh off of spring break. I hope everybody got those nice spray tans or actual tans, and I hope you guys are ready to finish off the year. And I hope you guys like jewelry, because we're learning a new derivative rule today. This is a final lesson in our rules of differentiation, and this chain rule has a lot of good it's a lot of good help, obviously, with derivatives, because it's another rule, but it's going to be really useful further on in calculus when we get to integrals. Let's begin with the chain rule. Thank God it works. Okay, what is the chain rule? It's a derivative rule for composite functions, actually. We haven't been working with composite functions. We've been mostly working with polynomials and just polynomials. So something like this, yeah, it's got a lot more going on. Something like this, we're throwing some trig in there now too, so that's even more complicated. Or something like this, right? Something inside, but now the whole thing is raised to the fourth power. So what do we do about these? Okay, we're going to use this chain rule. Now, composite functions can be written like f of g of x. So like there's like this outer function f, and embedded in it is this inner function g of x. And if we look back at this example, you could see that our f of x in this case would be that x to the fourth power. Whatever is being raised to the fourth power, that is the outer function. The inner function, g of x, is this x squared minus 2 piece right here. So you could think about it as having two different pieces. Same thing with this one too, but I think this is an easier one to see. We have the whole thing, the outer function, our f of x, is x to the 1/2. We're taking this whole thing to the 1/2 power, or taking the whole thing to the square root. Our g of x would be this 2x plus 3. So now that we kind of have a better idea what I mean by that, instead of using f of g of x, we're going to be working with f of u, okay, where u is g of x. We're just going to call it u, all right? So the derivative of fu is going to equal f prime of u times u prime. So it's going to be like this derivative of the outer function with the inner function inside, multiplied by the derivative of the inner function. We're going to see what that looks like in a little bit here, okay? I call it I call it the foo method, but as you can probably hear, it doesn't sound like that. I don't care what you call it. It's the chain rule, and it's kind of fun. All right, so if I say fu, don't take it personal, all right? So the derivative of fu, and using this guy, we're going to use it with one of these examples. Y equals 2x plus 3, all raised to the 1/2 power. So when you're doing these problems, it might be a good idea at first, until you feel comfortable, to write it out like this. You know, state what your inner and outer functions are, then state what your derivatives are, and then put it all together using this foo method right here. All right. So what we're going to do is we're going to do it together right now. Hello, hi, it's me. Okay. Really zoomed in. Let's actually do some of these problems. Okay. So we'll start with that first one right here. And I have it written out for us. So given this function, our outer function is that 1/2 power, that x to the 1/2 power. And I'm just using x arbitrarily. It doesn't matter what I say it is. Something x is being raised to the 1/2 power. The inner function u is at 2x plus 3. All right. So now let's get the derivative of those guys. Well, the derivative of the outer function, if we use our power rule, because it's the only rule we know so far, we're going to take the 1/2, put it out in front, and we have to subtract 1 off this, so we'll end up getting negative 1 over 2, x to the 1/2 power like that. You can verify it with the power rule. And then the derivative of the inner function is just going to be 2. All right, so putting it all together. Put it all together with this method. So if I have some function and it is having the derivative taken of it, this is going to turn into f prime of u times u prime. This is our chain rule that we're working with. Okay. So our dy dx, or the fu prime, whatever you want to call it, is going to be this outer function, the derivative of it. So we ended up getting this guy right here. So it's negative 1 over 2. But inside that function is the original u function. It's this 2x plus 3. So instead of x, I'm going to plug in my 2x plus 3 and raise that to the 1/2 power. And now I need to multiply by my u prime. Well, my u prime was 2. So putting this all together, my derivative is negative 2 over 2 parentheses 2x plus 3 raised to the 1/2 power. And yes, we can simplify that further. These guys can cancel to 1 over 1. So this is negative 1 over, and I'll do the square root this time, the square root of 2x plus 3. And that would be the derivative of this guy up here. Who would have thought? You know what I mean? The chain rule would know what we meant by that, okay? So let's see it with another example. Let's try this guy right here, okay? This is all on the slide too, but it's right here. So, given y equals this stuff right here, again, we need our outer and our inner. Our outer function is going to be something x raised to the 4th power. Okay, this inner function is this x squared minus 2. Let's take the derivative. Derivative of f is 4x to the 3rd. Derivative of u will be 2x. Constant just goes away. So now putting this all together, again, using our chain rule. I'm going to take my derivative of my outer function, my fu prime. I guess I'll call these prime to make them a little bit more like this up here. Fu prime is 4x cubed, but instead of x, I'm going to plug in my inner u. So that was that x squared minus 2. And that whole thing is getting raised to the 3rd power. And then I have to multiply by u prime, which is this 2x. So putting it all together, dy dx is equal to 8x times x squared minus 2 raised to the 3rd power. Just simplifying it out. Okay, that guy is a derivative of that guy. Okay, kind of weird. I totally understand. Again, we're going to get one more rep out of this, and you're going to get some practice on your homework to try this. You just need to practice it. Okay. Again, outer function and inner function for this guy. Well, my outer function is this something is being raised to the 3rd power. Okay, so it's x to the 3rd power. My inner function is the x squared minus 5. Let's go ahead and take the derivative. Derivative of f is 3x squared. Derivative of u is going to just be 2x. And really, if you've noticed, we don't really need this part when we're kind of like doing this, right? We really just need, okay, again, using f prime of u, f prime of u is going to be 3 x squared minus 5 to the 2nd power. Again, just plugging this inner function into this outer function's derivative. And then I just have to multiply by the inner derivative. So multiply by 2x. And I end up getting 6x times x squared minus 5 raised to the 2nd power right there. All right. So this is Mr. Knight signing off. Your homework will be posted in Schoology. Have a great day.